most generally, we can shift the basic linear equation y equal to mx by adding c onto it. And this is simply a translation in the positive direction of the vertical axis. And this can be most easily visualized by considering the different y-intercepts as follows, because this line will necessarily pass through the point 0, c, because if you plug in x equal to 0, you get c. So y equal to mx plus c is really just y equal to mx shifted. If you keep the value of c constant, then variations of m will give you rotated versions of the line with the same y-intercept. And that's the reason why it's generally stated as the intercept form. So the first one, slope-intercept form, is basically the one we have seen, which is most commonly used. But there are also a few other common forms given for a line. The most important one is the point-slope form, which is written as follows: y minus y1 equals to mx minus x1, where x1, y1 is a point on this line. Notice how this is simply y equal to mx translated to the right by x1 units and up by y1 units. Thirdly, the general form can be written as ax plus by plus c, which equal to 0. But note how there's only really two independent coefficients, such that the line is actually the same as this one. So importantly, two parameters define a line. And as an example, we have given a particular line, or the picture of a particular line, and the same line written in various forms. This is the intercept form. This is the point slope form. And this is the general form. You often need to choose the form that matches the right information. So for example, if we are given that the line passes through 3, 4 and has a slope of 3, then we can write it in the point slope form as follows, where this is the y-coordinate, y1, and this is the slope, and this is the x-coordinate. So in the normal slope-intercept form, it's simply 3x minus 9 plus 4, which is nothing but 3x minus 5. Now, note that this form can be just visualized as the line 3x translated to pass through the point 3, 4, as follows.